Hello everyone and welcome to this afternoon's webinar from us here at EUMETSAT along with our partners from the OSI SAF and the Copernicus Marine Service, who you'll be learning more about during the course of today's presentations. We'll be talking about ocean surface scatterometry winds. My name is Hayley, I'm the moderator, and I'll be starting off today's webinar with just a short presentation to give you an overview of what we'll be doing and who we all are. So I'll just share my screen. Okay, hopefully you can all see my slides correctly now, but if not, one of my colleagues I'm sure will chime in and tell me. So as I said, my name is Hayley. I'm the lead marine applications expert here at EUMETSAT. So I have a responsibility towards our user engagement and training activities related to all our marine related products. Now, winds are not explicitly a marine related thing, but since we're talking about scatterometry over the ocean, this is why I'm here today, and also working with the colleagues from the OSI SAF and the Marine Service, who we'll talk more about now. So who are we at EUMETSAT? If you don't already know us, we are the European Organisation for the Exploitation of Meteorological Satellites. We're an international organisation with 30 different member states. You can see them all in the map of Europe on the right-hand side there. And we basically provide weather data and climate-related data for these member states for their national meteorological services. And beyond that, we also work a lot with other aspects of the European Earth Observation System, so the European Commission's Copernicus programme. And we also provide other data, value-added data, through partnerships in our member states with our satellite application facilities. And if you're interested in marine data, the one of interest there is our Ocean and Sea Ice Satellite Application Facility, the OSI SAF. And Gwen will be telling you a little bit more about them later on. We operate a whole bunch of satellites. This is a graphic that shows all the ones that we've been operating since 2003, and we will be operating up until 2040 in the planning timeline here, but we actually have plans that are going beyond that now. You can see that the number of satellites is growing, but you can also see that we operate them under three main sort of program types, if you like. The mandatory programs are where the majority of the weather-related data that you'll work with comes from. This is our Meteosat and Polar System satellites that you'll see there. We've just launched a couple more recently, and a growing number going forward. We also have our optional programs. So this is our altimetry, which also produces some wind-related data if you're interested. So starting with Jason 2, progressing into Jason 3. And then we move into the Copernicus program satellites. So we currently operate the Sentinel-3 and Sentinel-6 satellites as part of our commitments to the European Commission's Copernicus program from a marine perspective. Beyond that, we're actually operating now Sentinel-4 and 5 missions aboard our recently launched satellites, but that's more atmosphere related. So I'm sure you'll be able to attend some short courses on those in the coming months and years. Looking at the future, we'll be operating some more satellites under the Copernicus program. So the high priority candidate missions, which will now become the next Sentinels, so Simmer and Crystal. And we're already looking forward towards the next generation of these missions as well. So that's just a very quick overview of the marine satellites, related satellites that we operate. So how do we all fit together? At the moment, as I said, we at EUMETSAT operate some missions under Copernicus, so Sentinel-3, 6, and Jason-3. We are part of the space component of the program. We're one of the what they call entrusted entities, along with our colleagues at the European Space Agency, who operate the satellites in the space component. And we deliver the satellite data from the Sentinels down to the marine services and other services that use this data, such as the marine service operated by Mercator Ocean, which we'll also talk more about today in a presentation from Rianne. From our mandatory missions, so the METOP, MSG, and MTG programs that you can see there, we also work with a consortium of colleagues across Europe in the form of the OSI SAF, the Ocean and Sea Ice Satellite Application Facility, and they produce further data in the marine domain that can be used for different marine applications. And hence, we're all here today because it's all data that's relevant for you as users of this type of data. We run a series of short courses. This is, I think, number 50, so there's quite a lot of them. You can watch the recordings of them online on our classroom.eumetsat.in page, as well as register for upcoming ones. They're on a huge variety of different topics, data sets, tools, all sorts of things. And really, this is designed to support you out there, our users. So if you have ideas for things you'd like to hear from us, or if you'd indeed like to collaborate on one of these courses to showcase something you've been doing with our data or a tool, then of course do get in touch with us. You can email training@eumetsat.int. In terms of our agenda today, you've got the welcome and introduction from me, and then Gwen will give you a tour of the OSI SAF, followed by an overview of the OSI SAF WINS catalogue from our colleague Anton. And then we will have Rianne presenting on the Copernicus Marine Service and their wind catalogue. We'll wrap up the webinar with a use case from the IPMA from Portugal, from Nuno Moreira, on the usage of these wind products around certain storms and different activities that he's working on. And then we'll have some time to answer some questions, which we will be collecting on Slido. If you have any broad questions about our training, you can contact training@eumetsat.int. That's our training email. You can find out all of our courses and events on trainingevents.eumetsat.int, and there's a couple of marine ones coming up later this year and early this year that may be of interest. If you need any general support on our EUMETSAT products, you can also contact ops@eumetsat.int, as well as the help desks that will be advertised by my colleagues at the OSI SAF and the Marine Service coming up. But if you remember that one, we'll make sure you get to the right colleague, even if it's not us. So thank you very much, and I will hand over to Gwen for the next part of our webinar.
Yes, hello everyone. I'm just sharing my screen. So, yeah, everyone can see my screen, right? So I'm gonna give you a short presentation about just to briefly present what OSI SAF is, because there's a bunch of names that we are using and that some of you might not be used to. And then I will have as well 2 slides to present important concept that we are using in our catalogs, and that will help you understand better the catalogs and probably what Anton and Rianne will be saying afterward. This is just a short introduction to what they are gonna present. First, OSI SAF. So EUMETSAT is actually delegating part of its production efforts to some consortium inside its member states. So there are 8 of them, and the name of this working group are SAF, Satellite Application Facility. One of them, ours, is OSI SAF, which is concentrating on ocean and sea ice. So in this working group, we have teams from the Norwegian Meteorological Institute, the Danish Meteorological Institute, Météo-France, which I'm part of, and IPMA, and of course the KNMI, the Royal Netherlands Meteorological Institute, which is today doing this webinar with us because producing our wind data. And this working group, this consortium, works on producing data on ocean winds, but as well on sea surface temperature and sea ice. So for ocean winds, as we will, Anton will explain us, we are producing data of scatterometer winds. And then about the first main topic that is important to keep in mind when you're going through the catalogs of EUMETSAT and Copernicus is we have 2 big types of data. You will meet the near real-time data and the climate data record. So first, the near real-time data. EUMETSAT is the core function is to produce data for meteorological use, where the production time is crucial. The fastest the data comes into the end of the users, the better. So the choice is always done to produce the data at a faster rate over high quality. So if you as users need the data from the same day with the shortest latency, the shorter production time, then you should go for the near real-time data. But then we often do some reprocessing, which we call the climate data records. And this data, we take more time to process them, so the quality is the quality is better, but it takes longer time to process. You need a few time to get the data. The example I put on the slide of latency are for sea ice data. It's similar over the other with a slight difference for each data set, of course. But for instance, for sea ice data, near real-time data will have 3 hours, 3.5 hour latency for the L2, which means you're getting the data 3 hours and 40 minutes after the satellite observed the sea ice. And for L3, you will have for 5 to 6 hour latency. While if you look on under the climate data records, the latency for climate data is up to 2 weeks. So it's 2 weeks. All data are of no use for meteorological uses. So, and then the second point that I already started to use the vocabulary in my previous slide. I said L2, L3, which is the level of processing of the data. Here in this webinar, it will be crucial because Anton and Rianne are presenting 2 different parts of this catalog. So we are using these terms from 0 to 4 to specify how was processed the satellite data. The level 0 will be the raw data that the satellite dump, just reconstructs without the communication end. And this data is not distributed at all. EUMETSAT is getting this data from the dumping station for the the polar orbiting satellite. Sorry, it's in Svalbard. They get the data from there and geolocates the sensor data and send that back to the institution working on the data. So OSI SAF is mainly working with level 1 processed by EUMETSAT. In the institute working on producing data, then we get the level 1 data and we process the data for it to fit to a physical parameter that we want to observe. So in our case, the KNMI get the level 1 data from ASCAT in the example shown on the image and process it to retrieve the wind direction and the wind speed out from the radar backscatter. This level 2 is what Anton is going to talk you about. This is the EUMETSAT the OSI SAF Scatterometer wind product. And then with this data level 2, KNMI also process some level 3, which means level 3 will be in that case an aggregation of the wind retrieval over a time period. So it's daily retrieval that are gathered and distributed by ascending passes or descending passes by sensor in Copernicus. And KNMI process as well a level 4, so where they aggregate several sensors. So it's the level 4 is multi-sensors, and they add model data to fill the gap. So it's not purely observation at the other level. It's based on observation. This level 3 and level 4, Rianne will talk you further about this. So that's it from me. I'm handing it over to Anton, I guess. And if you have questions, please answer in the slide.
Thank you, Gwen. Yes, now we will hand over to Anton. If anyone has any questions on Gwen's presentation, please use the Slido link. You'll find it in chat. We'll come to those at the end.
Okay, thank you. Good morning to everybody. Yes, I think there we are. Okay, thank you again. So good morning. So my talk will be about the OSI SAF wind catalog, and this is the outline, but we go straight to the first topic, and first topic is what is a scatterometer at all, and how can it measure winds? So the scatterometer is a radar instrument. It can measure ocean wind speed and direction, so two parameters from space. And here you see an image of the METOP satellites, and the ASCAT radar antennas are mounted at the underside. You can see the three different antennas all pointing in different directions, and this is important. I'll come back to that later. But scatterometry, it all starts with ripples on the ocean. These ripples are typically have a wavelength of a few centimeters, and the microwaves that the radar uses also have a wavelength of a couple of centimeters. So these match more or less, which means that the radar backscatter is sensitive to these ripples. And if you look at the right-hand side image, so if there's no wind, the ocean surface is smooth. And if we have an incident wave from the radar, it will be reflected away, so the radar will get very little backscattered signal. If there's some wind, the ocean will be a bit rougher, and some of the radiation will be backscattered back to the instrument, so we get a higher signal level. And if the ocean is very rough with a high wind, then even more of the microwave radiation is backscattered, so we get an even higher backscatter signal. So it's proportional to the wind speed, what we see back in the radar, but it's not only dependent on the wind speed, but also in the wind direction. So it matters whether the wind is pointing in the direction of the antenna or just away from it, or just perpendicular. So that all makes a difference. So that's a quite complicated relationship, but it can help us to retrieve wind speed and wind direction. And one other thing to mention is that these ripples are instantaneous. So when the wind is there, the ripples are there. If the wind is not anymore there, then the ripples will also vanish. This is different from swell and longer waves that you can see on the sea. So it's really sensitive to wind. So if we look at the top image here, then we can see how the scatterometer can actually observe the ocean from three different directions. So the satellite is moving in this direction, and if we look at one point at the ocean, first it will be covered by a forward-looking antenna, then by a sideways-looking antenna, and then by a backwards-looking antenna. So we get three observations from three different directions, and if we combine all these views, we get enough information to retrieve the wind speed and the wind direction. So we have three observations, and we only need two parameters. The wind speed and the wind direction. So the retrieval is overdetermined, and that means that we need little or no background information to retrieve the wind. So we hardly need any information from, for example, numerical weather prediction models or so. So the ASCAT has two SWATs, one pointing at the right side of the satellite track and one at the left side of the satellite track. And these tracks, these SWATs are subdivided into wind vector cells, as we call them. They are typically 25 kilometer or 12.5 kilometer in size. And at the bottom, you can see an image south of Ireland with the individual wind vector cells in one of the two SWATs of ASCAT. Yeah, maybe it's good. So the scatterometer is not the only radar instrument used on satellites. So we also have altimeters. They are also radar, but they are looking straight downward and not at an angle. They have some sensitivity to wind speed, but not for wind direction. And they are used to measure sea surface height, sea level, and so they are less usable for wind retrievals. And we also have the SAR instrument. You see the Sentinel-1 as an example here in the bottom image. It's also a radar. It has a very high resolution, typically 100 to 1000 meter, but it only has one view on the ocean and not a multiple direction views like the scatterometer. So it cannot resolve the speed and direction by itself. It needs extra information, for example, for numerical wind speed for wind direction. So the SAR cannot retrieve winds with the same quality as the scatterometer, although the resolution is higher. So let's move on to the OSI SAF wind products. As said already by Gwenaël, the OSI SAF only provides wind products on the swath grid, so what we call level 2. So you can see 2 examples here on the right-hand side from different satellites. So the level 2 products are really the most timely products. As soon as we get data from the satellites, the level 2 is produced, and they are typically organized in files with a couple of minutes or one orbit of the satellite. And they are typically used for numerical weather prediction models for data assimilation. And also they can be used for visualization because they are available quite fast. Level 3 and 4 products, as mentioned, and this also will be explained by Rianne, are organized on lat-long grids, latitude-longitude grids, and they are easier to use, but they are not as timely as the level 2. So in the OSI SAF, we use data from European satellites, so METOP, ASCAT, the Chinese Haiyang series. They also carry scatterometers. And Indian satellites, so SCATSAT is not operational anymore, but we use OceanSat 3 currently. And we use as many satellites and instruments as we can to get optimal coverage of wind data. So the better the coverage, the more impact we get on weather forecast. And we also provide climate data records on level 2 from several past missions, and actually they already start from 1992. So you can see some examples here. The near real-time data are disseminated through the EUMETSAT satellite system by EUMETSAT, and they're also available on FTP server. And the data formats that we support are buffer and netCDF. And you can also retrieve the historic data, so both the historic near real-time data and the climate data records from the EUMETSAT data center. So I have a couple of slides on satellite wind product viewers that are available online to the public. So here we see an example of EUMETView, which is the EUMETSAT on the EUMETSAT user portal. It provides many layers from different instruments and satellites, so you can easily select what you want to see, and ASCAT is also part of this. But it's only ASCAT, so the other satellites that the OSI SAF produces are not yet in. But it's very nice tool, and you can really combine nicely what you want to see. So here you see an ASCAT winds together with a infrared cloud image from a geostationary satellite. Then there is a site from NOAA NESDIS. It also provides wind visualizations from European and Indian missions, including history. It's quite easy to access, and it's nice that you can go back in time very far. Then we have the Copernicus Marine Service visualizations, but Rianne will say more about that. And finally, we have the KNMI Scatterometer website, where we show wind data from all the near real-time OSI SAF wind products. You can choose between arrow displays and barbs and some other options. And it also has geostationary imagery in the back, but it only shows the data for the last couple of days, so there's not much history on this site. So this is an example. It's the multi-platform product viewer. So it brings together all the scatterometer winds from OSI SAF from one day. So then you can see on this world plot that we really cover all the oceans. And if you click somewhere on this plot, you get a detail image. This is ASCAT, and you can also go back in time on the right-hand side and see the wind products from different satellites. So in that way, you can see a history back around 20 minutes. So that makes it easy to see how certain systems develop. So then a few words about the future of OSI SAF winds. So next year, METOP second generation B satellite will be launched. It will carry a SCA instrument, which is the successor of ASCAT. This new instrument will resemble ASCAT, but it will have somewhat broader measurement spots, so a better coverage, and also an extra channel with cross polarization. I will not go into the detail, but it's more sensitive to high wind speeds, so it can more accurately measure the hurricane winds speeds. So that's for the near future. And at the same time, we are also working on higher resolution winds products. So for ASCAT currently, we have 12.5 kilometer products, like here in the left-hand side plot. These are operational, and we also have a demonstration product at 6 kilometers. So especially for visualizations and to look into details, that will be very useful. So that's to come for the future. So my final remarks for this talk. So the OSI SAF delivers level 2 wind products. They are the timeliest products and closest to what the satellite measures. But they are not the most convenient ones to use. Rianne will say more about level 3 and level 4. These level 2 products are always organized per satellite and per spatial resolution. So for each instrument, we have a separate product in level 2. And for the most of the instruments, we also provide products on different spatial resolutions. So that makes quite a lot of products. So here are a couple of websites that you can go to for more information. And of course, also you can contact our help desks at KNMI or OSI SAF. So that's it for me for now. So I will stop sharing.
Thank you very much, Anton. If anyone has any questions for Anton, the Slido link is still in the chat there. I can see a couple of questions have come in already, which is great. We'll address those at the end. So for now, I'm going to hand over to Rianne to talk about the Copernicus Marine Service winds.
Yes, hello everyone. I will tell you more about the level 3 and level 4 products that we produce for the Copernicus Marine Service. So I will first shortly introduce the Copernicus Marine Service, tell you about the level 3 and level 4 products that we produce for scatterometers, how you can access these products and download them, what we plan for the upcoming years, and I will also say a little bit about the SAR products that are also provided through the Copernicus Marine Service. So the Copernicus Marine Service is one of the 6 services in the EU Copernicus program. You might also know CAMS, which is the Atmospheric Service, or C3S, which is the Climate Change Service. And the Copernicus Marine Service provides free and open marine data, both from observations, which can be both satellites or in situ observations, and from ocean models. And it's managed by Mercator Ocean International from France. The Copernicus Marine Service offers both global products, but also products specifically targeted for the European seas. And they provide really a wealth of different variables. A couple of them are mentioned here, and wind is just one of them, and the one we are focusing on today. Anton already gave you a lot of information about the level 2 products that are produced in the OSI SAF, which are provide the observation on the original swath grid, so aligned with the grid. But yeah, this grid changes every time for every new swath, so that can be complicated if you want to, for example, average in time, or you want to compare different products. So that's why we also produce level 3 products, which where we interpolate the observations to a regular latitude longitude grid, so it's north-south oriented. And then for some applications, it is necessary to have global coverage, homogeneous fields, for example, for forcing models. And for those purposes, we also produce level 4 products. And in our case, it's a combination of observations and model fields. We actually use ECMWF hourly model wind fields, and then apply a bias correction, which is based on scatterometer observations to remove persistent biases in the model fields. But I will tell you more about this later in the presentation. So here is an overview of the level 3 and level 4 scatterometer products that we provide. For level 3, we both have a near real-time and a multi-year product, which are complementary, similar in structure, and available at different resolutions. So what these products provide is these are daily products where all the SWOTs over one day are combined into one product, and we still separate the ascending and descending SWOTs, so we prevent overlap between the SWOTs. Still, for at the high latitudes, we have a little bit of overlap, even for ascending and descending, or for the ascending SWOTs separately. So there we only keep the last observation of the day. And these are available in different spatial resolutions depending on the instrument. The near real-time product is available after one day. So today you can get the observations for yesterday, and the multi-year product after about 4 months. And then we have level 4 products. There's two, a near real-time and a multi-year level 4 products that have an hourly tempo resolution. Yes. So, and the near real-time product is provided for the past 2 years, while the multi-year product goes back to 1994. And there's a monthly product as well for those users who do not need this very high temporal resolution, which also means there's a lot of data and large files. So this is an overview of the variables that we provide in the product. So we both provide ocean surface wind, but also ocean surface wind stress, which is calculated from the wind. And then we provide the vector components, so the zonal eastward and the meridional northward component, the magnitude, and also the spatial derivatives, which are divergence and the rotation, which can be also very interesting for certain applications. And in addition to the variables provided from the scatterometer observations, the products also include collocated ECMWF model wind and stress variables. So for every location and time where we have a scatterometer observation, we also have the corresponding ECMWF model output. This is a timeline of the scatterometer observations that we provide in the level 3 product. So in the multi-year product, there's various satellites. These are reprocessed data sets, and there's always a bit of overlap between different data sets. Well, for the near real-time product, we have a large number of scatterometers. We add them as soon as they are released, and the quality is sufficient. And currently we have 5 operational satellites, 2 ASCAT instruments, 1 OSCAT, and 2 HSCAT. And regarding the collocated ECMWF model fields, there's operational model winds in the near real-time product, and for the multi-year product, we use ERA 5 reanalysis winds. The level 4 product, as I already mentioned, it's a combination of observations and model fields. And if you compare scatterometer observations with model winds, then you find very persistent biases which do not change much over time or only change slowly. So what we do is we actually calculate this bias over a sufficiently long period to remove any sampling effects, in this case 20 days, and then we add this bias to the uncorrected, the original ECMWF model field, and then we end up with a bias corrected model field. If you, for example, look at this location, this is in the tropical Atlantic, where biases are typically large, like up to 2 meters per second, then this correction provides more spatial variability and also larger gradients. For the level 4 product, we use a similar timeline of scatterometers combinations with always some overlap. And the near real-time product is only the past 2 years. And similar to the level 3 product, we use operational ECMWF model winds for the near real-time product and ERA 5 reanalysis winds for the multi-year product. Anton already has shown you a lot of different viewers, but Copernicus Marine Service also has a viewer where you can look at the different products they provide in different ways as well. They also provide trajectories and things you can look at, and you can really customize the viewer to what you like. You can change color maps, ranges, and combine different data sets. You can zoom into regions and click on a certain point, see time series. And you can also use the viewer to download data for your region or period of interest. But there's also a product page for every product where you can find more information, also the user manual, quality information, and also a link again to the viewer. And if you go to data access, there's also multiple ways to download data. So you can also get a nice overview of which data sets are available for what periods. You can create a subset of the data or download the complete files. For those that are used to working with more GIS approaches, there's also different options. And there is a toolbox which you can use in a Python environment to download the data in a more automatic way. So what we plan to do in the upcoming years, we will keep extending the near real-time products with newly available scatterometer instruments. So we expect additional Haiyang instruments, another OceanSat, OSCAT instrument, and also, as Anton already mentioned, SCA. There's currently an ongoing reprocessing of the METOP A ASCAT dataset, and also we anticipate METOP B ASCAT dataset reprocessing. So these will be updated in the upcoming years, both the level 2, the level 3, and the level 4 datasets. And we're also continuously working on improvement of the level 4 products, for example, in coastal regions, or by using more scatterometers in for the most recent years where we have a lot of scatterometers. Then there's also SAR products in the Copernicus Marine Service. These are level 3 products with a very high resolution of about 1 kilometer. These are regional products, so they're only available for the European seas, and they are produced not by KNMI, but by CLS and IPMA. And yeah, as Anton already mentioned, these have a high resolution, but because it's a different type of instrument, the accuracy is also different than for scatterometers, but it's a complementary product to scatterometers, and we're also using it ourselves to compare and to improve both the SAR products and the scatterometer products. So I'd like to end with an overview because, well, there's many products, many different levels, and you might wonder what would be most appropriate for your application. So if you require high timeliness and or a high accuracy, so really the original winds, then the level 2 products are the ones to use. If you want to do more statistical approach, averaging or compare different data sets, different variables, then the level 3 is more appropriate also because there's additional variables provided. And if you really need global coverage and or a high temporal resolution, then the level 4 hourly products are there for you. And if you think, well, I don't need that much data, I just need to know what the wind field is on a longer time scale, for example, for simple model studies, then there's the level 4 monthly product. And that's all I wanted to tell you today. So thank you for your attention. And you can ask your questions in the slide.
Thank you very much, Rianne. That was a really great overview of all the different products available there through the Marine Service and the data viewer and things as well. As Rianne said, Slido is there for you to ask your questions, which we'll come to very shortly after our final presentation, which is a recorded one from our colleague Nuno, who unfortunately couldn't join us today. He's going to share a little bit about the usage of the Scatterometer wind products at IPMA.
Hello, everyone. My name is Nuno Moreira. I'm the one here on the left on the screen. And I will talk to you today about the usage of Scatterometer wind products at IPMA, with contributions from my colleague Bruno Café, also from IPMA. In today's talk, in a nutshell, I will mention Scatterometer wind data that supports monitoring at IPMA of extratropical cyclones, local winds, and tropical storms and transitions. Let's start with the extratropical cyclones and some glimpse at the North Atlantic. I will start with kind of an old storm. It's already 15 years now. So from 2010, it was Cynthia's storm. It was truly European because it formed in the middle of the Atlantic, but then it passed in the Gulf of Biscay, in the North Sea, and in the Baltic Sea. It lasted for 6 days between the end of February and beginning of March 2010. Impacted many countries in Europe, as I mentioned, and we could have 8 ASCAT views in different life cycle instances of this storm. This case served also as the base of an EUMETSAT training module on ASCAT winds that was called the Cynthia Storm by ASCAT, which you can find in this link. I will show you now some of these instances and some of the scatterometer data that we could have. This is in the beginning where you have here the center of the storm and you have the species on the side of the storm. But later we could really have a pass over the center of the storm. So this is already on 26. Then again on the middle of 26, you could have here a clear change in the wind direction in this area here. And it was already the deepening phase of the storm. Again, here with the clear change in the wind direction and the position of the center of the depression. And when it was approaching the Iberian Peninsula on the 27th, and here in the Gulf of Biscay, a very nice image with the winds for this storm. Of course, we have been studying and analyzing cases of storms with ASCAT. And in the EUMETSAT weather briefings, we have analyzed many of them. This is the case from January 2021, Gaetan. We have also here Eunice from February 2022. I will talk about it a little more in a minute. This is the case for the interaction of the ex-Hurricane Franklin with an extratropical low on September 2023. And here Eowyn on January 2025. and Armenia also in January 2025. Regarding EUNIS, this is a very nice overlay between the ASCAT sea winds at 12.5 kilometer resolution with the air mass RGB from Meteosat second generation. And you can see here clearly the sting jet in the image pattern, and you could check that the highest surface winds here in red are really in the tip of this sting. So this is a very nice combination of these two kind of observations. You could see it here more clearly. You have here to the south of the depression, you have even 55 knots of wind. Another storm was Eowyn, again with the sting jet, and it again depicted by ASCAT. And you can here see the combination of many passes with the strong winds in this southern part or southern border of the storm. And this was in a more recent storm. Regarding local winds, I will talk to you about the Nortada, which is a very local wind here in Portugal, and which the oceanic part is clearly shown by scatterometers. As I mentioned, it affects the mainland's Portugal west coast, and it's very typical during spring and mainly during summer. In the mesoscale, it results from the combination of the sea breeze with the Iberian terminal low circulation, and it fits the coastal low-level jet conceptual model. And also, it causes upwelling of colder waters to the surface here in the west coast. This Nortada can, in this case, sometimes or alternate with easterly winds. This was the case in September last year, 2024, where you can have the scatterometer data depicting the change of wind direction between the morning here on the left and the afternoon here on the right. So you have the easterly winds here in the morning, and then the northerly winds in the afternoon. This was a situation of severe forest fires here in Portugal that were driven by these continental easterly winds. And in this case, this Nortada wind coming from the north appeared, but only temporarily, not allowing significant moisture transport inland. Regarding tropical cyclones and transitions, I will give you a sample of the 2024 season. So I will start with Kirk, which transitioned to extratropical close to the Azores. Here it's the islands of Corvo and Flores from the Azores archipelago. This was happening in October 2024, and you could see ASCAT here showing in the northwest quadrant and the southeast quadrant winds up to 55 knots. In the post-mortem report from National Hurricane Center, they even attributed to, at this time, 65 knots for wind. And this storm was very close to the Azores Islands, so around 800 kilometers. Another case in 2024 was subtropical storm Patty, already in November 2024. And in this case, we could measure with the scatterometer winds up to 40 knots in the west quadrant. And you can see also very close to the Corvo and Flores Islands. This is a combination with ASCAT and the Meteosat third generation cloud phase RGB. So this is just in a nutshell some of the examples that I could show you on the usage of scatterometer data at IPMA. Thank you very much.
Thank you to Nuno in his absence for that nice summary of how the scatterometry data can be used around lots and lots of different storms. So this brings us to the end of our webinar. We have a few questions in the Slido, which hopefully will appear shortly, and we will try and get some answers to these questions for you. Okay. So first question there is from Pallavi. Thank you very much. How do we know the quality of the observations? Is there any kind of quality assessment provided? So maybe Anton or Rianne, would you like to comment on this one? So Anton first, maybe?
Yes, I can comment on that. Yeah, so generally we compare the scatterometer winds with ECMWF model winds and also with buoy winds. So we use winds from moored buoys over the oceans to compare the scatterometer winds with, and we do this on a regular basis in the OSI SAF. So there's half-yearly operational reports provided in the OSI SAF, and there you can read about the quality. So generally, we have something like, so usually the wind speed bias that we observe with scatterometers, it's usually less than half a meter per second, and at least that's about what we maximum allow. But in practice, it's even better. And for a long time, so for climate data records, the stability of the data of the wind data records, it's in the order of better than 0.1 meter per second over 10 years or so.
Great, thank you, Anton. Rianne, is there anything you'd like to add from your side on the quality assessment of the products?
Yes, more on the products itself, maybe, because the products also contain the quality flags for the individual observations, and also there's in the user manual, there's a table explaining what these mean, and that's both in the level 2 product and also in the level 3 product. So for every observation, you can also see what the quality is, if there were any issues during the processing, or if there's any suspicion that this observation may be of lower quality.
Okay, thank you very much. Next question is on the 5.6 kilometer ASCAT data. Anton, are you able to provide any more information about how these are processed, or maybe point to some resources?
Yes. Yeah, so in principle, the way the winds are retrieved at 5.6 kilometers, it's not different from the other products. The only thing which really makes these products different is that for the most resolutions, we define a regular grid with 12.5 kilometer or 25 kilometer spacing, and then the full resolution observations from the instrument are fitted onto that grid. With this 5.6 kilometer product, we use the resolution of the instrument itself. So the wind vector cells positions are exactly matched to what the satellite observes, which reduces the interpolation errors. And so it fits to the natural resolution of the ASCAT instrument. But from there on, we process it just like other winds, and we are still, so this is a demonstration product today. We're still looking into the validation and how to optimize it and things like that. But the winds already look quite promising, so it's already a good product. And yeah, we are eager to hear feedback from users, of course.
Thank you very much. Okay, then we have another question from Sebastian. I think this one was asked before Nuno's presentation, potentially, because we saw quite a few examples in there. But Rianne, maybe then Anton, do you want to comment on the use of the winds around tropical cyclones in particular? Oh, we can't hear you, Rianne. I think you're muted.
Sorry. Yeah, I think this question is also mainly about whether there's data sets specifically for tropical cyclones. I don't think, well, I'm not aware of any that really, single out the tropical cyclones. But of course, the global data sets do include the tropical cyclones. But yeah, then you need to combine in with some, other databases of cyclone tracks to really pick out the cases. So I don't think at the moment that there's a specific data set for scatterometer winds around cyclones, but maybe Anton knows.
No, I think, yeah, so there have been projects looking into this, and I know, yeah, so maybe some databases of cyclones exist, but I don't know exactly. And of course, yeah, so the climate data records of winds, they contain it all. So yeah, so currently you have to have some prior knowledge about where the cyclone happened to find it back.
If this is something of interest, maybe it's something we can look into, showing an example of how to match up some of these databases with our data sets. So I can take an action on that, because it sounds like it'd be quite a fun thing to do. Okay. And so we have a question here from Zakaya about the Scatterometer level 3 wind data from Copernicus, and is it reliable for validating NWF models near the coasts, and what different distance to the coast can we rely on them? So I think this is probably one for Rianne to answer, but maybe Anton can also offer something.
Yeah, I'll have a go. Yes, well, we think that the Scatterometer wind data are reliable near the coast. And well, we provide also the quality flags in the product with the observations, so users can also check whether there's any issues with deriving the winds, which may occur maybe a little bit more often near the coast, but we only derive the winds in those at those locations where they are not influenced by the coast, or we specifically exclude the effects of the coast on the wind. So we think we really are able to provide the winds close to the coast, while on the other hand, in comparison with numerical weather prediction models, we often see that the models tend to already see the coast before they actually get there. So they are actually probably more sensitive to the distance to the coast. But it's very hard in coastal areas to validate also the Scatterometer products. There are buoy observations available, but these are also usually in specific environments, and also when there might be very local effects. So it's hard to say which is the real truth.
Yeah, so I can add to that maybe. So specifically for the ASCAT case, the ASCAT instrument, we have made some progress in the past years to get winds closer to the coast. So we used to have winds until around 20 kilometers from the coast, but due to some changes in the level 1 process, we are now able to retrieve winds up to around 10 to 15 kilometers from the coast. And yeah, so they have been validated with buoys, and they are of good quality. But as Rianne already said, the validation itself is also challenging due to varying local effects. So yes, we can rely on them, but yeah, there's still more work to do. But this is one of the topics OSI SAF and Copernicus are working on to improve, in particular, coastal wind retrievals, because we know coastal winds are quite important for society.
Thank you both very much. And if there are no more questions, then I think we can close the webinar here. Just a quick reminder that you will receive a link to the page for this course, where you can complete a quiz and fill in some feedback for us if you would like. And if you do that, we can also offer you a certificate to prove that you attended the course. So thank you all very much for attending today, and thank you again to all of the presenters for the informative webinar. Thank you.